Okay, so here's the first question let's take a look at. Stuff like this. Stuff like this. So they're giving you weekly salary of a manager is $700 plus 10% commission, right? That's got to be the slope, percent. Okay, so then we can see that the function is going to be, our starting value plus the slope 0.1. 10% is a decimal is 0.1x. What's tricky about this one is how are you going to graph the line on this graph? It's not a very convenient graph, right? Look at this graph here. It goes by the vertical axis goes by 100s and the horizontal axis goes by thousands. And so let's just say hypothetically that you had something like this. Like what if your function was, what is it? It's supposed to be, I think it's s of x. Is that what it is? Do you remember what it was?
700 plus 0.10x.
Okay. And I think it was salary. So I think it was s of x. Yeah, I think that's right. Okay, so if we had something like this, if we had s of x equals, let's just say ours was 600 plus 0.15x. Okay. So would you agree that our y-intercept is 600, right? The slope is 0.15. That's what's inconvenient. So here's our y-intercept. But if I write the slope as 0.15, well, what is 0.15 as a fraction? 1500ths. Okay, that's one way to write this. Would be 15 over 100. That's not convenient though, is it? Because on our graph, going up by 15, that's not going to work well, right? These go by 100. So going up by 15 puts us at a really awkward spot in between places where the graph crosses. So what could we do with this slope to make it more convenient? This is what I really want to show you on this problem that I think is very helpful. What could we do? Yeah, I could multiply the top and the bottom both by 10. How about, right? If I multiply the top and the bottom each by 10, I'm just adding a 0 on the top and the bottom, essentially, right? I get 150 over 1,000. That's better. Still not perfect, though, because 150 still puts me in between. So we're getting there. How could I tweak it a little bit more? Because I'm going by hundreds on the vertical axis, thousands on the horizontal axis. Double the top and the bottom, right? If I multiply the top and the bottom each by 2, I'm going to write that fraction as 300 over 2,000. That would be convenient, wouldn't it? Now, look what that would do. If we started here, we could rise in this case by 300. We're going to run by 2,000, which is 2 increments. And now we've got 2 points. So I could connect and extend, and I got it. Right? Make sense? Okay, and then the last part of this problem is really no big deal. It's just like all the other linear model problems that we've done in the past. They just want to know if we input a salary of 2,000. No, it's not. Sorry. Oh, yeah, right. If her weekly salary. What is her weekly salary? Right. If her sales were 2,000. So sales are input, right? So this would just be inputting 2,000 into our function up there. No big deal, right? Plugging in 2,000 for X to see what the output would be. Part D is a little different. Part D is saying if her weekly salary, that's the output number, was 1,300, what would the weekly sales have been? Well, then we would just look at this graph probably, right? If we go over at 1,300, it looks like the intersection occurs there, and so the input would have been 6,000. We could do that mathematically by just setting the output S of X equal to 1,300 and solving for X also. Okay? All right, so there's there's first one. Okay, let's keep going though. What do you say? we go and look at something like, okay, how about something like that? Okay, one like that, and I've got one of those already copied. Something like that, right? So this is one where we've got to come up with a function, linear function C of S. Now, if we read through this, the number of calories burned in 1 hour on a treadmill is a function of the speed of the treadmill. So then speed is the input, right? If we say it's a function of speed, we always say the output is a function of the input. So speed's the input, calories would be the output, okay? They want us to come up with a function here. Well, look at the stuff they give us. Think about this in terms of a graph always. If I were going to graph this thing, what do we have? Well, the input we said was speed, so that's S. The output is C, and we would just have ordered pairs. Instead of X and Y, we have S and C. So then what ordered pair does this information tell us? Walking on a treadmill at a speed of 2.1 miles per hour will burn 270 calories. What does that tell us? How could I write that information in a way that would make sense in terms of this graph? How would I organize the numbers? How do I organize inputs and outputs on a graph? Okay, output's Y, input is like X, right? And how do I write them though? Ordered pair. Yeah, that's just an ordered pair, isn't it? We've got this blue ordered pair up here, input of 2.1, output of 270, right? Okay. How about this information? At 6 miles per hour, the person will burn about 370 calories. Another ordered pair where the input is 6, the output is 370. Okay, so now we just got to think about how would we come up with the equation of a line if I have two ordered pairs? We got to calculate a slope, right? So let's do that. Let's calculate a slope. So m would equal y minus y, or in this case, I mean, you know what I mean? Y in this case is really c. So output minus output, so right minus left, over 6 minus 2.1. So what's that give us? 100 over 3.9. Okay, that's some weird decimal. Going to give us some bizarre decimal. What would that be? Somebody quickly throw that on your phone, or what's that going to be? Lillian, what's that going to be if I do 100 divided by 3.9?
What did you say?
100 divided by 3.9. It's
25.64.
okay, so there's our slope, right? Now we have a point, we have 2 points, and we have a slope. So how would I come up with the equation of the line? How do we do that? Point slope, exactly. We use point slope. Good. So instead of, now, normally point slope would look like y minus y1 equals m times x minus x1. But we're going to do a little switcheroo here, right? Instead of y, we've got c. And our value, how about if we use this point right there? Okay, so that's the point we're using. So c minus 370 equals, instead of m, we're plugging in 25.64 times the quantity. Instead of x, that's going to be s minus, and we're using the red point, aren't we? So s minus 6. There's our line, isn't it? Okay, all we have to do, if we want to write this, we want to isolate the c and write this as a, c as a function of s, is just distribute that slope and add 370 to both sides, and we're done. Okay, good? All right. And then we can use the function that we build in part C. Okay? Okay, what's next? I'm not sure if that's, let me move forward here and just see if that's the right one. Move forward through the test. Yeah, we don't need to do that one. Okay, so this is just a straightforward linear regression problem, isn't it? All right, if we want to do one like this, let me make this a little bigger so you can see what's going on. We're just going to go into Desmos. Unfortunately, you can't cut and paste this because they've got those darn years in there, and that's not very convenient. I tried to reprogram that question, and it wouldn't work. I spent entirely too much time on it. Is that the right? Yeah, okay. No, oh my gosh, that's not quite right, is it? A little bit off. Yeah, you bet. Okay, so we're going to put in this data. What do we get here? 292, 333. Darn it. Here, you got to tell you what, if you guys read these off to me slowly.
358. 381. 401.
Okay, there we go. So then I'm going to build my regression equation. Remember how we do that, right? We're going to use the lists. So y1 tilde m x1 plus b gives us the values of m and b, right? So we should be able to use that to fill in this information right there, right? If I round that to the 100th, to 2 decimal places, would everybody agree that rounds to 20.03 is m, and 301.76, right? Okay. What about this next part? They want the average monthly cost to workers for family health insurance in 2021 is predicted to be what? Okay, well, 2021 corresponds to what year? I guess that would be 12. Everybody agree? Because 2011 is 2, so 10 more than that would be 12. So how could I conveniently use this stuff? I would go down and create a function using the m and b that the regression gave me. So I just build the function f of x equals mx plus b and plug in 12, and it gives me 542 point, what do they want it rounded to? The nearest cent. Oh, that's a little bit off. Look at that. Okay, you know why? Because this is kind of dumb. Because why is their answer different than mine, and mine is better? No, they don't. But mine is definitely better. What did they do instead? They used the rounded numbers in their function, right? So they plugged in 12 into this equation, and that gives you 542.12. Why is mine better? Because it's better because the rule is when you're doing applications of math, physics, chemistry, anything like that, you don't round until the final step. There's no reason to, right? If technology is storing all those extra sig figs, use them, right? So I used a bunch of extra sig figs, and so mine unrounded gave me a little bit closer answer. So what's that mean on the test? I guess on the test you better do the dumb thing and just use this equation instead. Okay, when you plug this stuff in. I mean, if you didn't, I'm still going to try to catch that and give you credit, but just play it safe. Just plug into the equation that you build in part A. Correlation coefficient, there it is, right there, right? Rounded to 3 places, 0.982. Remember, that's R, not R squared. Okay, good? Everybody good with all that? Okay. Tell you what, let's put all that stuff in here. How about? Okay, there. I'll put that. I'll publish all this in the notes. All right, moving on. Next one. Okay, stuff like this. That is by far the easiest question on the test by a mile. How do you find the answer to that one? So what do you do? Don't even have to. Doesn't make any difference. Just put it in Desmos, right? You don't have to do. This is just. What's the point of this question? I'm just trying to have you guys use and remember a really easy way to solve a linear system using technology. Graph the lines and find the intersection. So all we've got to do here, picture of this. So we're just going to go into Desmos and we're just going to graph these lines, right? So we're going to graph 4/3 x plus y equals 0.6. And we're going to graph 0.7x minus y equals 3. And this shouldn't both be blue, should they? And then we're going to find that intersection, which is right there. And what do you know? So rounded to the nearest thousandth, that's 1.770 and negative 1.761. Okay. Do we have to have that 0 there? No, you don't even have to include that 0. If the third digit's a 0, just leave it off. Either way. Okay. So let's get a picture of that. How about? Yeah. Okay. Okay, next one. I've got one like this all queued up. How about something like that? Okay, in a special diet for a hospital patient, the total amount per meal of food groups A, B, and C must be 360 grams. The diet should include 1/3 as much of group A as of group B, and the sum of the amounts of group A and group C should equal twice the amount of group B. So here's the question. The question gives away what the variables are going to be, right? So the question is asking, how many grams of each food group should be included? Okay, so those are the variables. We need 3 of them because there's 3 food groups. So we'll say A equals grams of A. How about if we do it as a little a? So A is going to equal the grams of food group A, B is going to equal grams of food group B, and C is going to equal grams of food group C, right? There's our variables. We've got 3 variables, so how many equations do we need? Got to have 3, right? We've got to have 3, at least 3. So we got to somehow come up with that. Well, does this tell us something? The total amount of per meal of food groups A, B, and C must equal 360 grams. What's that tell us? A is grams of A, B is grams of B, C is grams of C. The total amount per meal of food groups A, B, and C must equal 360 grams. There you go. So we got one equation. The red equation would be A plus B plus C equals 360. Okay? What else can we come up with here? Let's see. We know, here's something, some more information. The diet should include 1/3 as much of group A as of group B. Okay? That's tricky wording a little bit, isn't it? So which one's bigger, A or B? B is, isn't it? How much bigger is B than A? Well, okay, so A is 1/3 as big as B, right? B is how many times bigger than A? 3, right? Okay, so we could say this one of two ways. I could say A equals 1/3 B, or I would probably say it this way. B equals 3A, right? When you're unsure about this, throw some numbers in there and just see. Like, let's just say, what if group B was 30 grams? What would group A be? We have 1/3 as much of group A as of group B. So if B is 30, what would A be? 10, right? So that would help us come up with that equation, wouldn't it? Okay. Okay, so we come up with another equation there. Now we need one more. Let's see, it tells us the sum of the amounts of groups A and group C should equal twice the amount of group B. Okay, that's going to be an easy one because the equals is right in there, right?
Twice, 2B.
2B. There you go, right? Okay, there's our three equations. Now we want to solve these. We solve a 3x3 system because you have access to technology. So why would you do this algebraically? You're just going to do this using a matrix, right? But we got to put these into standard form. So the first one is already there. First one already looks like A plus B plus C equals 360. But we got to write this in alphabetical order of the variables on the left side, number on the right. Okay? So I could subtract the 3A over to the left side. Everybody agree? In the equation 2, and get negative 3A plus B equals 0, right? What about the bottom one? If I subtract the 2B over to the left side, I'm going to get A minus 2B plus C equals 0. Okay, Deegan, were you going to ask if I could have done 3A minus B there? Oh, okay, I thought you had a question. Okay, does that make sense? Because that would have worked too. We could have just as easily have subtracted the B to this side and made it 3A minus B equals 0. Still would have worked, okay? So there's going to be our linear system. Now all we've got to do is set up a matrix to solve that thing, right? Okay, so we'll jump into Desmos matrix. Okay, so we got to build a matrix. What are the dimensions of our new matrix going to be? 3 by 4. There you go. So what's the first row going to be? Okay, next row? 0. Okay, next one? Okay, good. And then I have to hit enter to store that. Then I do RREF of A, and that probably is going to look familiar. Yeah, look at that. What do you know? 40, 120, 200 are the values of A, B, and C. Okay? Good with all that? Is that good? Okay. Okay, what about one like this? Couple ways we could do this one, right? We could set up, we have 3 unknowns, don't we? Because we're supposed to write this function. supposed to plug in values for A, B, and C. So I have three unknowns, A, B, and C, which means I need three equations, right, for those A, B, and C. One way to do this would be to just use these solutions to set up three, each solution or each point gives us an equation. When x is -3, y is 1. So if I plug in -3 for x and 1 for y, wouldn't that give me 9a plus b times -3 is -3b plus c equals, and we always want to put the number on the other side, right? Equals y, which is 1. Okay, there's one equation. If I plug -1 in for x, I'm going to get 1a plus b times -1 is -b plus c equals my y value, which is 11. There's another equation. And here's a third. If I use that point, if I plug -2 in for a, -2 squared is 4. So 4a plus b times -2 is -2b plus c equals 9. That looks like a linear system, doesn't it? 3 by 3 linear system. Okay, so we could do the same trick as last time. Oh, don't give up. Okay, let's clear these guys. So new matrix, 3 by 4. Everybody agree I'm getting 9, -3, 1, 1, 1, -1, 1, 11, 9. Okay, good. Hit enter. There's my matrix. RREF of A gives us that. Aha. Okay. Okay. So that's telling us the values of A, B, and C, right? So then agreed, that's going to give me the function y equals -3x squared minus 7x plus 7. Okay. There is another cheap way to do this one that's kind of slick, right? If we go back to Desmos graphing, you remember how to do this one using Desmos graphing? Okay, there is a slick way to do this. We could use regression, but we'll use quadratic regression. So we've got these three ordered pairs. I could make a table out of that, right? Of x and y values. Let's call those x1 and y1. How about? Okay, and my x values are -3, -1, and -2. And the corresponding y values are 1, 11, 9. So I could come down here and now I'm going to use regression, but instead of y1 tilde m x1 plus b, I'm using that setup, right? I'm going to use, I'm going to use this function that I want to match. So y1 tilde, tilde a x1 squared plus b x1 plus c, r squared is 1, and what do you know? Look at my values of a, b, and c. Those look familiar, right? Take your pick. You have access to just an embarrassment of riches on this test in terms of technology. You got the whole thing, right? Okay, so if we were to use that technique, that also works. And here are the connections. A is -3. B is -7. C is positive 7. Okay? Make sense? All right. And is there, I think there might have been one more. Oh, yeah, and then this one's easy, right? This one, you guys got that one? I won't even mess with that one. I think everybody want to see that one? Okay, we're good with that one. I think that one's fine. Okay. Good enough.